So today I will be taking some problems of momental ellipsoid after a small gap. Okay. Now, so we have already discussed what is momental ellipsoid, and the equation of momental ellipsoid is ax square plus by square plus cz square minus 2dyz minus 2ezx minus 2fxy is equal to a constant. And all of you know what is the meaning of capital A, B, C, D, E, F. A is the moment of inertia of the body about x-axis. B, moment of inertia of the body about y-axis. C is moment of inertia about z-axis. D is product of inertia about x-axis. What does it mean? It means x will not be there. So, minus 2d yz, and then in minus 2e, what is E? Product of inertia about y-axis, and similarly, what is F? Product of inertia about z-axis. So this is the equation of momental ellipsoid, and now we have to find some momental ellipsoids, some cases, some questions I will be doing. The very first question which I am taking is of 3 dimension, that is to find the momental ellipsoid at a point on the edge of a hemisphere. All of you know hemisphere is a 3-dimensional body, a section of the sphere, that is hemisphere, half of the section from the diameter. So half of that will be hemisphere. Any arbitrary section of a sphere will be a disk, not a ring, it will be a disk. So let us cut it at a distance x from the x-axis. So this is a disk of width delta x I am taking. You know how to calculate the moment of inertia. I have already done so many lectures on it. That is, first of all, you consider a elementary slice, and then you calculate its moment of inertia, and then you integrate to get all such slices. They are placed close to each other. So when you cut this, it will be a disk. Okay. So point on the edge, it is taken as O, and the coordinates of G, center of gravity of the hemisphere, you know where it is? It will be at G, and the coordinates of G, x coordinate will be A, y coordinate will be 0, and z coordinate will be 3a by 8. So these are the coordinates of the center of gravity. Okay. Now let us work out. You know the procedure. First we will calculate A, B, C, D, E, F, and then put all these quantities here. We will get the required result. So the very first thing is A. Now A is moment of inertia of this elementary disk at a distance x from OX of width delta x integrated from 0 to A. Isn't it? In fact, this is the moment of inertia of the hemisphere about x-axis. But how to calculate moment of inertia of the hemisphere? First we will consider its section, disk, and then we will calculate the moment of inertia of that disk about x-axis, and then we will integrate from 0 to A. So this is what I am doing. So it will be 0 to A pi A square minus x square. What is this? This is the radius of the disk. You can observe this is the radius of the disk. This is A, this is x. So it will be under root of a square minus x square, and I need pi r square. So it will be pi a square minus x square dx into rho. This is in fact, when integrated from 0 to a, will give you the mass of the disk, mass of the solid sphere when integrated. When not integrated, that is simply the mass of the disk. So this term stands for mass, and then its moment of inertia of this hemisphere about this x-axis will be the moment of inertia of this disk about an axis passing through G and perpendicular to it, and then this mass into this x square. Why? I am using theorem of parallel axes. So moment of it, I am using the result, moment of inertia of a disk about an axis passing through its G and perpendicular to it. That means this axis, it will be 1/4 of mr square. Is that clear? Okay? Then to this mass into distance square, because this distance is x, so that is the theorem of parallel axis says that this will be the total moment of inertia of the hemisphere about x-axis. A very simple integration is here. You can integrate. You will get 4/15 pi rho a phi. I have already told you how to calculate rho in terms of capital M. That is, only this integration is equal to capital M. Integrate it and find out the density. Density will be 3m divided by 2 pi a cube. So when you put here the value of rho, you will get the value of a. It is 2/5 ma square. Okay. So if it is clear, then let us pass on to the next result. That means now I want to find the value of B. Value of B will be moment of inertia about x-axis plus ma square. Why? Again theorem of parallel axes. So it is coming as 7/5 ma square, and this is the case for C as well. So we found the value of A, B and then C. What next? We have to find the value of D, E and F. Now the value of D is summation MYZ. Now you know y coordinate is 0. So what will happen to it? It will become 0. So this is 0 because y is 0. Also F is also 0. Why? Because it also contains y and y is 0. Okay. So the only term which I will get will be E. E is summation M x z. Now what is x? X is A. What is z? Z is 3a by 8. So when I substitute here, it will be 3/8 ma square. That's all. Now put all these values in this equation. You will get the required result. Very simple. Okay. So that finishes this question. Now let me do one more question today, and that is to find the momental ellipsoid at a point on the edge of a next question. Now in this question I am going to find, this is a question of 2 dimension. We are not having a solid sphere, but we are having a ring. Okay, so let me do that. First of all, let me give you the question. Question is to find momental ellipsoid at the point on the edge of a circular base. A circular base of a hemispherical shell. Now, as I said in the last question, we were having the section in the form of a disc. But here it is not in the form of a disc, but it will be in the form of a ring. It will be in the form of a ring. So I am going to consider one such ring at a distance x of width delta x. Is that clear? Why it will be? Because we have a circular base of a hemispherical shell. Okay. So, circular base, circular ring. Of a hemispherical shell. So, again, we have to find similarly the values of A, B, C, D, E, F. Now what is it? It is known to you. Moment of inertia of a circular ring. Here the section will no more be a disc. It will be a ring whose width is delta x. So we have done in a question that the value of A will be 2 by 3 ma square. Okay. And then the value of B, here we have to use the theorem of parallel axis, that will be 2 by 3 ma square plus ma square. So it will be equivalent to 5 ma square by 3, and this is also the value of C. B and C, they will be equal. Okay. So we found the values of A, B, C. Now, what is CG? The coordinates of CG will be A, 0 and A by 2. A, 0 and A by 2. Now again, as we did in the last question, here D will be 0, will be F. And what will happen to E? E is MA into A by 2. So it will be MA square by 2. Okay. Now the question is done. You can put the values here, solve it. You will get the required momental ellipsoid as 2 by 2x square plus 5 y square plus z square is equal to 3zx plus constant. I hope the question is clear to all of you. So we did 2 questions this time. We found momental ellipsoid for 2 cases. One is solid hemispherical shell, another is a solid ring, hemispherical ring. So that's all for today. Now next time I will be taking again 2 more questions from momental ellipsoid. Thank you very much.